My name is Rodrigo Nader. I'm a co-founder of Langflow, part of DataStax. In this session, we're going to explore how Agentic AI is transforming development by diving into systems that reason, adapt, and take actions with Langflow. In the past few years, we've gone from machine learning models to deep neural nets, from rule-based automation to transformers that can reason and adapt. In 2024, we saw GPT-4 barrier basically being surpassed, and models at the same accuracy running on our own laptops. LLM prices crashed thanks to competition and open source progress, and we saw the rise of inference scaling reasoning models and the absurd shrinking of those massive models that still keep similar capabilities their parent models used to offer. And now, new architectures taking place with like MLA models and even diffusion LLMs. It's becoming more and more obvious that model development is no longer just evolving like in many other fields. It's accelerating its own progress. And that's why we're about to climb the curve you see in this graph at such a steep rate. Most advanced reasoning models today aren't just trained by humans. They're already being trained by other models with techniques like reinforcement learning and pipelines that synthesize reasoning data. We're also using models to help us code and figure new patterns in research. So AI is basically self-improving and at a pace that we've never seen before. But if model development is evolving at this near unstoppable pace, real-world systems aren't really keeping up with them. Models are evolving faster than we can deploy them, and the gap between capability and real-world application is widening. And that's the challenge we're here to talk about. In traditional software development, if you find a bug, you go into the function, trace the issue line by line, and fix the exact piece of code causing that problem. You basically have full control over the logic, right? But in Gen AI, that's not the case anymore. The core function of your application is the LLM. It is the language model, which means the part making key decisions is basically a black box. And that's due to multiple reasons. The first one is that language models are probabilistic, right? Second, we're usually constrained by providers' limitation. And even if not, let's be honest, these models are just too complex for us to dig into their inner workings. It becomes basically unfeasible. So instead of fixing bugs in the code base, AI developers spend most of their time tweaking inputs or adjusting prompts and expecting to see different outputs. And that's created a need for a new way of building software, one that brings much more interactivity, visibility, and control, with an intuitive and iterative approach, so that development feels more like guiding this evolving system instead of writing static code. And that's where Langflow comes in. Langflow is a completely open source framework for building AI applications. It allows you to connect models with other models and external systems, such as databases, APIs, local files, and it brings together models and components, such as vector stores for RAG, data processing functions, and hundreds of integrations to simplify the development process from experimentation and prototyping up to deployment. And over time, Langflow has evolved into this platform capable of handling a wide range of AI-driven tasks that usually subdivide into either an LLM-based automation, and these would be basically pipelines that have language models in the middle of them, or a RAG system where you need to add more context to your model and basically maybe vectorize some of the data for fast retrieval. And finally, agentic systems, right, which is exactly what we're going to focus today. So let's introduce the Langflow agent. An agent is basically a system powered by a language model that can reason and use tools to solve tasks. It differs from traditional functions we're used to for the fact that it sort of makes decisions. It has agency and thus its name. Langflow agents can analyze, plan, and decide which tools to use and what to do next. And it provides traceable intermediate steps, meaning full visibility into what the agent's doing, decision-making process, and all via Langflow's playground. Langflow works like a traditional workflow platform, where you have components, inputs, and outputs. But here's where it gets very powerful. Every component in Langflow can become a tool, and you're going to hear that a lot today. Existing applications, workflows, APIs, any component can be literally repurposed as a skill or ability for an agent to use. And you can define which fields or parameters the agent can control, keeping some of them sort of manual, making others fully agent-driven, and so on. And this is super important to make sure that we give agents just enough control. But a single agent can make a lot of mistakes for multiple reasons. First, more tools equals more errors. The agent needs to choose the right tool, and with too many options, mistakes become more likely. Second is that memory and context limitations raise problems. For example, the more tools an agent has, the larger its prompts and context, and it makes it harder to track previous actions. And then the third, ambiguity in tool selection can become a big problem as well. If multiple tools have similar or overlapping functions, the agent can struggle to pick the correct one. So it's just like a team of people, right? We sometimes need more specialized people coordinating together to solve a task. So instead of just using one agent that tries to solve everything, we build a multi-agent system where each agent is sort of focused on its own specific tasks. And for that, we can use an orchestrator or more than one that is going to manage decision making and decide sort of who solves what. And Langflow comes with a full suite of NVIDIA-powered components to enhance your AI workflows with state-of-the-art capabilities. It comes with NVIDIA NIMs to deploy LLMs as microservices, NEMO retrievers for embedding, re-ranking, and extraction, which you'll see right now, and NEMO Guardrails to add customizable safety layers. So let's put some of them to work. So we covered the theory and seen some components. Now it's time to build. In this demo, we'll go through 3 key steps. First one, building a basic agent. We'll just start with something very simple. Then we'll give it access to some tools and show how that process of creating a tool works. And third, we're basically going to create a financial report analysis pipeline, extract performance sentiment, and bring this entire workflow into the agentic ecosystem. Let's go. Okay, so here we have a Langflow agent. And in this flow, you can see only 3 components. The chat input is going to take in the user message and pass it over. We have the agent component itself, and this component has a couple of parameters you can define. So you can, for example, select a model provider, pass an API key, the model name, or a specific version to power this agent, and set instructions to guide how the agent will behave. And then there's a chat output component as well, which is going to send the agent's message back to the user. So if we just play this flow by itself, it would look something very similar to just calling a model. For example, let's open the playground, say something like, hey, and it should come back with a simple answer. Yeah, hello, how can I assist you today? Cool. So now what we can do is to start adding some tools. And tools for agents are like giving abilities to a brain. You're adding this capability that it wasn't able to access before. In this case, let's just start with something very simple, the calculator. I'm gonna drop it from the sidebar, and just like every other component in Langflow, the calculator takes inputs or parameters and sends an output. A component like the calculator will take a string with a math operation and compute the result. So let's test it with any number here. Could be 3 plus 5. Just run it, and let's see what comes out. Right? I can inspect the data output, and I'm gonna see that sure enough, yeah, 8 is the output. So it's working. But the thing here is that this calculator is working in a traditional workflow way. It gets inputs and gives outputs. Langflow has this special toggle called tool mode, which can instantly convert any component into a tool for your agent. It's basically going to take these components' functionalities and create tools out of them. So notice the toolset output. Let's plug it into the agent's tools input and check what happens when I try an operation from the playground. So let's enter some numbers that the language model wouldn't be able to compute by itself, and hope that it's going to use the calculator. Let's see. And there you go. So it executed the calculator component, and here we can open up the intermediate steps and inspect what the agent did. So basically, I see the JSON that it passed over to the tool, and I get the result it got back from that tool. And it brought me an answer based on the output from the calculator tool. And if you think along those lines, you can do a lot of similar things with many other Langflow components. And just with that, you can start to imagine how extrapolating that idea can bring a lot of power to your agents if you're doing the same thing but with a lot of different components from Langflow. Langflow has components for so many different tasks, and you can basically convert them into tools and empower your agents with them. For example, let's take a URL component. It takes a website as an input, and it just brings back basically the main page of it in a string format. So in this case, I'm just opening the langflow.org website and showing the output it brings up. And this is traditional workflow format, right? But again, the idea with Langflow is that everything can be a tool, right? So let's turn this URL into tool mode and connect that to our agent. So here I'm going to write something like going to langflow.org, and and bring me some basic information from the main page or something. Let's say access langflow.org and pull some info. And you're going to see how the agent already recognized that it needs to execute the URL component, right? It's using the function fetch content text. And it brought back the summary with the latest information in langflow.org, which is correct, right? So very nice. Now you can, again, inspect the intermediate steps of this agent and what it did. So here, for example, I'm seeing the JSON with the input the agent sent to the tool, to the URL tool, right? And what came out of that, which is the raw text, the messy raw text from the website. And it parsed it and brought it back a little bit summarized to me. This is probably one of the easiest ways out there to start playing around with agents and creating tools out of anything. And Langflow has a lot of components and a lot of pre-built functionality plus integrations and bundles. But the coolest thing, in my opinion, is when you start to use what we call custom components. Langflow is Python behind the scenes. So basically, you can create your own component, write your Python code, and make this thing become your own. Add your own dependencies, your own functionalities, create functions, multiple inputs, parameters, outputs, etc. And then with that, you have created your own component. So here I created a new custom component. And if you look at that menu bar item called code, you can open that up and literally edit or create your own Python code inside of the component. And that is going to determine the behavior of this component. What are the inputs of it? What are the outputs? And you're going to pass functions that define what the component is going to do. In this case, I'm creating something very, very simple. It's basically just a component that will count the number of chars in a string. Okay, so if you take a look, the input value is hello world. And if I inspect the data, the data output, you see that it counted the number of chars in hello world, which is 13. And that's silly, but here comes the magic again. If you remember, in Langflow, everything can be a tool, right? So we can basically turn on that tool mode toggle and pass that over the function that I just created to an agent to be able to use it, right? We are creating this new ability to an agent from scratch, literally from scratch, because here we're using Python code for it. And notice how when you turn something into tool mode, you're going to see that edit tools option button. So what you can do here is you can rename the tool that you just created and also add a description to it. And this description is super important as well because it's going to define where and how the agent should use it. You can add instructions or guidelines for when your agent should use it or even when not to use it. So I'm going to say the name is count chars and description count the number of chars in a string. That's very simple. In some cases, you may want to use much more nuanced descriptions and names to avoid confusion by the agent. And you may or may not want to change the display name and description of the component itself, and that's valid for tools, but also for standard components. So let's open the playground now and try to make the agent use this new tool that we just created. So the agent gave us a summary in the pass message. What I'm going to do is I'm going to say, count the number of chars in that text, right? Let's see. And sure enough, as you can see, and said the number of chars in that text is 578. So maybe let's inspect the intermediate steps to see exactly what the agent did. Right, so it received input, count the number of chars, it executed count chars. Here's the JSON it used, so basically the summary set over there before, and it received 578 as the output of this new custom function tool that we created, right? Super cool, right? That basically gives you unlimited capability in terms of what can be created with agentic pipelines in Langflow, right? How complex this kind of thing can get. You create an agent, you plug tools into it, you have a set of pre-built components you can already use, turn them into tools, or create your own tool where anything possible with code can become agentic, right? One of the issues with agents is that if you start giving too many tools to them, they start making more and more mistakes, right? And that's because the more tools you're giving to it, the harder it is to pick the right one. There are more tools with overlapping functions, and the context starts to get too long. So, how state of the art systems are mitigating that is by creating multi agent orchestration. And Langflow addressed that with a very intuitive and straightforward way, which is remember, everything can be a tool, right? So an agent itself can become a tool for another agent, and you can start creating these specialized agents where you have this hierarchical chain of agents calling each other, right? So you can have one agent being the orchestrator, and this orchestrator is going to call, let's say, a couple of other agents. And that can get recursively more complex and more powerful, right? With endless possibilities. Now let's get into something a bit more advanced. We're going to build a pipeline for a financial report analysis workflow that will ingest an earnings report, extract all the tables found in the raw text, send these tables to a language model, classify the performance sentiment based purely on the data from those tables, and then this is supposed to serve as a playground example for generating something like executive summaries based on insights derived from the financial data. And then we're going to show how we can convert this into another agent capability. So the idea here is to start by loading a PDF file, and in this case, let's use any public financial report. Here's the PDF, and you'll see a mix of textual content, titles, subtitles, bullet points, raw text, and unstructured data like these tables that you can see that are often found in financial reports like this. And the goal is going to be, let's take each one of these tables and try to analyze them and ignore everything else. So this document is being loaded by that file input component, and it will be processed using the NVIDIA NIMs retriever extraction component, which can properly parse, clean, and automatically structure parts of the document in ways to prepare it for LLM usage, be it for basic inference or even vector store ingestion. So through this component, you can choose to extract text, charts, tables, and even split text into relevant chunks to create meaningful embeddings. In this case, we're only interested in keeping the tables, so let's stick with it. And running the components, and by running the component, we can inspect the output and check what came out of it. And we can see that there are a couple columns extracted. So we have the text, which is the main part extracted. We have the file path, where it came from, a document type, and description. And the interesting part to us over here is exactly the text, right? What was properly extracted and parsed by the component. And each one of these rows contain a table that was extracted from the document. Notice how they come in pipe separated values, so string format, ready for our LLM inference. And we're sending these tables in a data frame format to a component called batch run. This component will run a language model through each one of the rows given a prompt. So our prompt here is basically, based on the values in this table, classify the financial performance as one of the categories. And we're doing like very negative, negative, positive, very positive, something like that. Just a playground example to show how batch categorization can happen in Langflow. And notice how the column we want to extract data from is called text. So we added that as the column name. And to execute the batch run component, we need a language model. So let's choose one of the NVIDIA available model names. Here I'm choosing Llama 3.2 3 billion. And let's execute the batch run component and check out the outputs. So you see that now it has a new column called model response, right? And it's basically doing what we ask for. It's the language model running through each one of the rows and computing the sentiment for each one of the tables. And what we can do with that data frame output is I can run some operations on it. So in this case, I want to do a value count so that I can get the number of values per category. Cool, right? Notice how I've frozen some of the outputs on some of those components, and that's to avoid the component to run again. Finally, let's run this through our playground. In the playground, if I run this flow, I'm gonna get an output showing the response by the entire pipeline. And this is super cool, but it's still a traditional processing pipeline. So how can we make this agentic? So remember that the punchline of this presentation is everything can be a tool. So why don't we convert this entire workflow into a tool to our old agent friend? So here I'm back with it. We have the URL, the calculator, and our custom component tool, all of them plugged into our agent. And now we're gonna drag a new component called runFlow and load the previous flow that we just created and convert that into a tool for this agent. The runFlow component allows you to choose any other flow in your project, and it will automatically convert it into a component itself in another flow, right? And like everything else, it has a tool mode toggle that we can activate. So in this case, I'm loading the financial categories flow and running it so that we can see the output it comes up with. And there you go. It's the same output that we got from the flow itself. So now let's turn it into a tool and edit the name and description. Let's say financial report, and something like extract tables from a financial report and categorize their sentiment. Okay, so I'll plug this into the agent and open the playground for us to try it out. Let's try to make it use the sentiment report to generate some sort of executive summary. So use the financial report. Use the financial report to make an exec summary about the company's performance. Cool, so it generated a executive summary showing a little bit of what the table report indicated to it. A strong overall performance with 13 very positive and 3 positive reviews. However, there are 12 negative. Yeah, that's super cool, right? And we can inspect, if we check the intermediate steps, or basically what the agent did to get there, we can see that it accessed the right tool and it got the sentiment report and used it to generate the summary. And by this point, you may have noticed how creative and unlimited this thing can get, right? You have flows that call other flows. You have agents that call other agents. Everything can be a tool, and you can connect things in a hierarchical style that goes much beyond traditional workflows and basic agentic systems. So hope you enjoyed this demo. Now, I want you to imagine a space where humans and agents could work together seamlessly. Some sort of task manager where humans and AIs create, assign, and review tasks. We're stepping into a collaborative intelligence world, but not necessarily humans collaborating with each other. Agents will decide how and when to execute an act, and will be responsible for approving or rejecting that work. Add differentiable or retrainable layers behind such systems where approved tasks could reward or improve a unified brain behind the scenes, and AI stops being just useful and starts becoming something more. With Langflow, we aim to redefine the way that we create and interact with these AIs, transforming complexity into control, agents into collaborators, and quickly turning ideas into reality. So if you haven't, check out our repository right now. Just scan this QR code. And don't forget to leave us a star. Thank you all for attending.